Hello guys. In previous video, we have discussed physical and chemical properties of metals. We have also discussed about formation of ionic bonds. So, let's continue with metals and non-metals. Here, we will be starting with extraction of metals. That means how we obtain metal for our use. We do this by a process known as metallurgy. First, we should understand few terms related with it. Natural materials in which metals or their compounds are found in earth crust are called minerals. Minerals are found in earth crust. Ore is the mineral from which metal can be extracted profitably, efficiently, and conveniently. That means ore is such minerals form which the process of extraction of metals is convenient, economical, and effective. The gauge particles are the impurities present in ore. The first thing is needed to be done to remove gauge particle from the ores. This process is known as enrichment or concentration of ore. There are various ways for concentration of ore. After concentration, there are different ways for the extraction of metal, depending upon the reactivity of metals. Metal with low reactivity are sodium, potassium, magnesium, calcium, aluminium can be extracted by electrolysis. NaCl can be considered as ore of sodium metal. After electrolysis, sodium metal is obtained at cathode. Let's see how metal present at the middle in reactivity series are extracted. Such metals are zinc, iron, etc. The ores can be in form of oxides, sulfides, or carbonates. The oxides ores directly reduced. Other ores are first converted into oxide ores using chemical processes and then reduced to the metal. Calcination. It is the process in which an ore is heated strongly in the absence of air. This is the process for carbonate ore. By this, water is expelled from hydrated ores. Also, carbonate ore is converted into oxide. Calamine is the carbonate ore of zinc. Here is the equation. ZnCO3 decomposes to give ZnO plus CO2. Roasting. It is the process in which ore is heated strongly in presence of air. Usually, sulfide ore are converted into metal oxide by the process. Zinc blende is strongly heated in presence of air. 2ZnS react with 3O2 to give 2ZnO plus 2SO2. After converting metals into oxides, it is then needed to be reduced to obtain metal. The various process of reduction has been mentioned here. First one is reduction by carbon. Coke is generally used to reduce oxides to metal for metals in middle inactivity series. Here is an chemical equation representing reduction of zinc oxide by carbon. ZnO react with C, that will give Zn plus CO. Next is reduction by aluminium. Manganese metal is extracted from its oxide using aluminium powder as reducing agent. Such reactions are highly exothermic. Here is the equation. MnO2 react with 4Al, that will give 3Mn plus 2Al2O3 plus heat. Also, iron can be reduced by the process. This reaction is highly exothermic. Even iron melts by the heat generated. Since iron is obtained in molten form from the reaction, thus the reaction is used to fill iron in broken railway track. This reaction, due to large amount of heat generated from it, is also known as thermite reaction. Next is metals lower in reactivity series such as copper, mercury, etc. Such metals are first converted into oxide by roasting. On further heating, they are reduced to metal. Here are equations. HgS react with O2, that give HgO plus SO2, or 2HgO is heated to give 2Hg plus O2. Similarly, copper glance is ore of copper. It is heated strongly in presence of air. It is first converted into copper oxide and then reduced to copper. The following equations cover the process. So by such process, metals are obtained, but still impurities are there. Now, the impurities are removed by the process of refining. Electrolytic refining is one of such processes. Let's understand the process. This is the diagram of initial setup of reaction. Anode is impure block of copper which is to be refined. Cathode is pure strip of copper metal. Electrolyte is solution of copper sulfate. Let's see how it works. At anode, copper from impure block of copper gains positive charge and generated copper ions go to electrolytic solution of copper sulfate. At cathode, positively charged copper ions from electrolytic solution of copper sulfate goes to cathode. It is accumulated at cathode. So, finally copper from impure block get charged and dissolve in electrolyte. The same amount of copper ions from electrolytic solutions gains electrons at cathode, become copper metal and get deposited at cathode. So, we get pure copper metal at cathode. The soluble impurities get dissolved and insoluble impurities get deposited below anode, known as anode mud. Corrosion of metal means a layer of metal compound is formed over metal. This is undesirable because metals lose its shine and strength. Lot of money is spent to prevent metal from getting corroded. Here are few examples of corrosions of metal. Rusting of iron. Rust is brown layer formed by action of air and moisture on iron. This something can be observed on iron metal kept around. This is the chemical equation representing rust formation due to moisture and oxygen present in atmosphere. Other examples are black layer on silver and green layer on copper metal. Methods from prevention of corrosion. Some of them are painting. Metal's contact is cut with moisture and air by painting the metal. Oiling or greasing. Grease is applied over metal to cut its contact with moisture or air. Galvanization. Coating of thin layer of zinc is done on iron to prevent it from rusting. Zinc is metal, does not corrode in damp air. It works even if the zinc coat is broken from somewhere. This is due to the fact that zinc is more reactive than iron and it oxides before iron and hence iron is protected. Tin or chromium plating. Tin and chromium metal are resistant to corrosion. Using electricity, tin or chromium is plated over iron. It is done on tiffin box, car bumpers, etc. Alloying. Metal and non-metal are mixed with other metal and non-metals to form an alloy. For example, iron is mixed with carbon to form steel. Steel is corrosion resistant. We will learn more about alloys. Let's learn something more about alloys. Besides protection from corrosion, alloys have other applications. They enhance the shine and strength of the metal. Here are few examples of alloys. Steel. Iron is used mostly in form of alloys so that its strength gets improvised. Steel is the alloy of iron and carbon. Carbon is mixed in very small amount, 0.05%. Steel is used mainly for making nails, screws, bridges and railways, etc. Stainless steel. It is an alloy of iron, chromium and nickel. Stainless steel is a strong alloy and also rust proof. It is used in making cooking utensils, surgical instruments. Duralumin. It is an alloy of aluminium. Aluminium is mixed with small amount of magnesium, copper. It is a strong and light alloy basically used mainly for making airplanes. Magnesium. It is an alloy of aluminium used for making beam balance. It is also light and strong. Brass. Brass is an alloy of copper and zinc, which is used for making vessels, utensils. Amalgam. Amalgam is an alloy of mercury. Bronze. An alloy of copper and tin, which is used for making coins, medals, etc., etc. There is difference in physical properties of alloys and metals. Both brass and bronze are not good conductor of electricity. whereas copper, which is the main constituent of both brass and bronze, is used for making electrical circuits. This implies property of alloy are much different from its element. So guys, that's all about metals and non-metals for you. Thank you.